This presentation is about the St. Mary Axe, also known as the Gherkin in London. This is presented to you by Kwabena Safo. This page is the content page. It introduces us to the whole presentation. I start with the introduction, followed by the figures and facts of dimensions, foundation, and also material used, which is mainly steel frames, and followed by general structure, elements of the facets, floors, roofing, and then finally the conclusion and reference. 30 St. Mary's Axe was designed by Foster and Partners, Fosrich RE, who are the owners of the building, and the main contractors were Skanska, and also their Arup was the civil engineering company that supported the structural work of the building. This building was completed in 2003. For this presentation, we'll be looking at outline of the structure of the building, the type of foundation, materials used, and also sustainability of the building. This page is to present to you the key facts of the building. This is a very big building situated in London, and the height to the dome above ground level is 179.8 meters. It's got 40 floors, and it's got a single basement. The floor area, that's the floor area covered by the building, this one is 47,950 square meters. And it's a multi-functional building that has got different activities going on there. We've got offices, we've got retail sector, we've got areas for gym, areas for meetings. So different activities actually goes on in this building. Looking at the construction technology which was used to build this building, by first considering the foundation, it comprises of 750 millimeter diameter straight shifted piles. Yes, and then the number of piles were 333. The total design capacity was 117,000 tons. All piles were done on the same day. And the reason why the piles foundation was used is because of the nature of the soil. The soil it's got very low density, and due to that, you have to dig the pile to be able to meet the high density soil so that it can hold the building, the capacity, the load of the building, and it can hold the structure in place. And this is the best way to go about a building like this. This is how it was constructed. Although the picture here is not exactly the piles, but it's a similar one, which just to demonstrate how the pile was done. This is to demonstrate the basic material used for this building. As you can see from the picture, this whole building was constructed with steel frames. And looking at it, we've got different sizes of steel frames, and we've got different columns and different beams. We have 29% of die grids, 24% of columns and beams. The reason why the ground level columns were thicker, if we look at it properly, the ground level columns to level 2 was 508 millimeters, and then the level 36 to 38 was 273 millimeters, because the ground floor column was thicker to hold the building in place, the weight of the building, and then transfer it to the foundation. So the die grid, if you look at it, that is the diamond shape, like as it is in the picture, diamond shape, and this also hold the floors, and also the cladding, which is the uh, the glass cladding, which was to attach to the building. And using steel was very effective in a sense that is because steel is very light and it can be easily assembled as well. If we look at the advantages of using steel frame is can be easily assembled and it can be done faster. We can have long span, and also it can support the weight of the building directly onto the foundation. It has a superior strength to weight ratio, like the amount of, if you look at the size and also the weight, it hasn't, because it's a tall building, using steel frame reduce the weight of the building. And also it's got greater resistance to rods and fungi attack, and even distribution of weight. And the floors, with this, the floors were laid on top of the steel frames, which actually supported them evenly and spread the weight of the load directly onto the foundation. Steel frames are also easily transported. So with that, if you look at the amount of steel frames in the building, then they were all transported directly to the site without any constraints because of the size of each steel frame. This is to demonstrate the design of the steel nodes, which serves as a connector to connect the various parts of the building together without any constraints. If you look at it very carefully, it's 360 degrees steel nodes were prefabricated in the factory. The steel nodes connect the complex diagrams together and also holds the floors in place. And with this, it helps to reduce the amount of columns in the building. With the design of the diagram and the steel nodes, it helps the diagrams to be connected straightforward and also cost effective for the building. This slide demonstrates the elements of the facets. So if you look at it very carefully, we have openable glass screeds and perforable aluminum levers, as internal sun screeds, and also a column case in aluminum. We have faced frame of extruded aluminum, and also if you look at the whole building, the cladding, it covers 24,000 square meters. And with this, because it's all cladded with glass, they're able to get a lot of sunlight into the building, a lot of daylight, and in a way it's a sustainable for reducing the consumption of energy. And also you can easily see through the glass and look outside because the whole thing is cladded with glass. Looking at the general structure of the building, the diagram exterior structure resists the baffling from the wind, and also it holds the building in place, which in a way helps to reduce the number of columns used in the building. And aside, there are a lot of big office spaces to be used. Also, the Gherkin shape of the building is environmental friendly, which allows free flow of air around the whole place, the building. If you look at the 5 wedge rotation shapes and the 6 wedge shaped light wells, and also the 5 rotation of floors, the 5-degree rotation of floors, this allow sunlight penetration into the building and also free flow of air. And in a way, it helps to reduce the energy consumption, as you know, as there is free flow of air in the building. It's actually sustainable and environmental friendly, which allows free movement of air into the building. The floors of this building are mostly visible and were constructed with concrete slabs supported by steel frames. The die grids provides vertical support to the floors, which are usually allow free office space. And aside, there are big office space without any interruptions. The visible floors breaks down the barriers. Like if you stand on one floor, you can see from the other side as well. You can see at the other floors as well. And because the floors are visible, there are a lot of ample amount of daylight which can come through to the building, and as such reduce energy consumption. And with this, the level of air condition used is also reduced, which is an effective way, an environmental and sustainable way of reducing energy. The, The roof of this building was constructed with steel frames as well. So as you can see from the picture, we have the vertical and the horizontal connections, which are mostly the diagrams. They were connected to the top of the building. And as you can see from the dome, it's all an open space. So there is no actual coverage. The coverage is all glass, which actually allow a lot of sunlight and also daylight to go through the offices at the top. And the way that the top has been also constructed, the top of the building, you can see can have a 360-degree view all around the city. As there are no partitions, you can go all around and have a look at London City with a 360-degree view. And because of the way it's been constructed, it gives a lot of daylight as well, which helps them to save energy. Looking at the sustainability of this building in general, the way the building has been designed has got a big impact on wind, and as such, the pressure on winds cannot directly affect the building as it can wrap around it. And also with that, this restrict the movements of the tower, because most long buildings, if there is a pressure on the wind, it tilts to some degree. It can swing to some degree, and because this building has been aerodynamically designed, the wind can easily wrap around it, and then it reduces the pressure on the building, the pressure of wind on the building. If you compare this to a tower block, which is a square tower block, in the same confined area as this building has been built, if there is a square tower block in this location where this building has been built, the pressure on it will be quite enormous because of the nature of the land, the size of the land, and also the surrounding areas. So with the aerodynamics used design used for this building, it's one of the best way to reduce the pressure on wing in the movement of the building. If we look at the 6 fingers of accommodation on each floors, the way it's been designed also allow a lot of daylight and also free movement of air into the building, and as such they are able to save a lot of energy for reduced number of air conditions and also daylight coming to the building. If we look at the facets design with advanced glazing technology and ventilation and blinds, it provides about 85% solar protection. So although the whole building is designed with glass all around, cladded all around, however, the amount of daylight or direct sunshine we can have impact on people's life is reduced by 85%, which is quite a great and also one of the best technologies to use to reduce the the impact on the direct sunshine, the solar to the on people's life. As a building, overall energy consumption is 50%, and since it's used only gas, the carbon emission is very low, and this gives the general sustainability of the building. And as such, the way it was constructed is one of the best ways that a building should be constructed. Some of the obstacles encountered in the construction of this building were mainly location, soil type, and complexity of the steel frames. Looking at the location, the building is located at a very busy place in London, and with this, the construction managers needed to manage supply chain and logistics very well for the free movement of traffic for the delivery of materials. To solve part of this problem, all piles and pile caps were constructed in a day, which was a good strategy to reduce the amount of traffic. Looking at the soil type, the cohesive soil type was not great, and therefore the best option was to use pile foundation, which can hold the load bearing capacity of a structure like this. Also, if you look at the complexity of the various parts of the and sizes of the steel frame, it was something which needed to be looked at properly. Bringing all of them together to form a structure like this would be very challenging. Although they were able to do it with their technology and also expertise to encounter all of these obstacles to produce an iconic building. In conclusion, 30 St. Mary Axe is an iconic building which has combined modern method of construction and sustainability to produce a unique building, especially saving 50% energy, free flow of air, and natural sunlight in the building. The way the building was constructed with steel frames, glass panel, and the aerodynamic shape resist movements of wind and also wind pressure, which makes it a very unique building of its kind.